Super excited to have Dr. Christopher Nash and Tamate here. I hope I pronounced your name correctly.
Yep.
We're going to go ahead and let you two give yourselves a little more of a rounded introduction, and then you can jump into your talk.
Perfect. Hello, everyone, and welcome to the dawn of AI in medical education. So, AI is everywhere right now, and people are using it for all kinds of things. But how much of that is evidence based? And how important are AI strategies that you use when you're doing your prompt engineering? And how do you know whether or not generative AI is reliable when using it for assessment in medical education? So, Chris Nash and I are both EM docs, and today we'll be demonstrating a process that you can use to leverage widely available large language models like ChatGPT to grade your students' medical notes. We've published all of our code under an MIT open license with a description of how you can build a similar system at your own institutions. There's a link to the GitHub that's in the chat. But before we get started, let's just show you how it works. While I've been talking, Chris is pulling up a Python script. He's going to load up a batch of student-written notes, all of the grading rubrics, and then execute the Python script. And that's it. The AI is grading them as we speak. There are about 15 notes in there, and it'll take around 10 to 15 minutes. And so we'll come back to check on the output when it's done. But while we're waiting, we're going to describe how we built this thing and why it's built the way it is, how to run similar code at your own institution, some of the interesting alternative uses that we found for this, and then finally, the future directions for this project and where we think the research should go. Similarly, the technology and approaches that we'll describe here can likely be adapted to other use cases, or at least we think so, but we'll talk about that at the end. So if you can't stay to the end of the meeting, feel free to drop your name and contact information in the chat. And we have a lot to cover in about 30 minutes. And so I'm going to talk fast. So without any further ado, my name is Tamate. I'm a pediatric emergency medicine doc at the University of Kentucky and one of the course directors for the third-year clinical medicine clerkship for medical students. I am primarily the audio portion of this presentation.
And I'm Chris Nash. I'm an emergency doc and core faculty at Duke. I'm a medical education researcher, and I focus on the integration of tech into med ed, including through the development of assessment tools for clinical training. And I will be primarily the visual component of this presentation as I now mute myself back off.
Chris was the primary architect for all of this software. And so while we want this to be as interactive as possible, you're going to notice that he's going to be doing things in real time. And so all of this stuff, none of this was actually recorded. So we are part of the NBME's SEEF Fellowship Program, which provides focused research training to an international group of early career faculty with a focus on medical education assessment research. And so our group of 8 is studying artificial intelligence and simulation-based assessment. And we are super lucky to have the mentorship of Dean Jennifer Kogan from the University of Pennsylvania and Professor Larry Gruppen from the University of Michigan, who, if you know them, are both renowned leaders in modern medical education. But we have become obsessed with building sophisticated open source AI systems for assessment that we can use to release to the broader med ed community. And the hope is to jumpstart the AI revolution in medical education by doing the technical work of studying the prompt engineering and the coding and the validation so that schools around the country don't all need to duplicate these efforts. And we wanted to study whether or not the current generation of large language models can assess written clinical reasoning. But as a first step in that process, we chose to start with developing a system that automates OSCE note grading. These are notes written by students after a standardized patient encounter. And the idea was this gave us a rubric and a framework to evaluate how well AI assesses clinical reasoning by comparing the grades it assigns to student notes with those given by trained faculty experts using the same rubrics. At the University of Kentucky, our roughly 160 third-year medical students complete about 9 OSCEs throughout the year. Each of these is graded twice to optimize fairness and validity, which means that our faculty grade almost 3,000 student-written notes per year. We estimate that this takes about 432 physician hours annually, or about $54,000 a year just for this one course. And while we split the work across 18 graders to share the load, this will naturally introduce variability in scoring. But here's how the process works currently. Faculty follow these strict rubrics with clear lists of required elements, like you're seeing here on the screen. They compare the student's notes to the rubric, they'll tally up the elements, and then they'll assign a score. Our rubric here is holistic, which means that it's not a checklist, and it allows graders to use some amount of professional judgment to account for strong reasoning or plans that don't perfectly fit into the rubric. Your institution probably follows a similar process, and the challenge that we face is the same: grading a large volume of high-stakes notes quickly, consistently, and fairly. But hand grading is time-consuming and well known to be prone to variability and subject to all kinds of bias. And doesn't using a structured rubric to assess written clinical language just sound like something perfectly suited for a large language model? For decades, people have seen automated grading as a white whale, not just in medicine, but across education more broadly. In May of 2022, the NBME even held a $50,000 competition to develop a natural language processor that could automatically grade medical notes. And then 5 months later, ChatGPT came out, and it blew the doors off of text-based reasoning. And we are not the first to use a large language model to grade student notes. Way back in July of last year, a study at Uniformed Services University showed that ChatGPT outperformed standardized patients when they scored free text clinical notes. And then in November of last year, UT Southwestern published their article about how AI could accurately grade notes after the rubrics were converted into checklists. In fact, we can do a simple version of ask AI to grade your note from scratch right now. And we're going to try that. This is what we call vibe coding. Chris has uploaded a rubric and a note straight into, this is not vibe coding yet. Chris has uploaded a rubric and a note straight into ChatGPT and asked it to grade the note. And so as you can see here, he is literally just the off-the-shelf model, throwing all of your information into ChatGPT. It's graded the history at a 3 out of 4, and then it gives you some explanations about the strengths and the weaknesses. So you can see all the scores and the reasoning there. But is it accurate enough? Is it consistent enough to be trusted with summative evaluations? Or is the technology just not there yet? What are the right prompts? Where do you set your temperature? How often does it make mistakes? What does it mean to hallucinate? If we run this algorithm over and over again, how often are you going to get the same responses? The problem that we're faced with is not, can an LLM grade notes? You just saw ChatGPT do that for us. The real challenge is proving that this non-deterministic, black box technology can reliably grade your students' work with the rigor that we demand in academic medicine. Is the score that it just gave us right? Is it even close? That's the purpose of this demonstration, to show you how to get it started at your own institution, to share some of our insights, and then present the evidence that we've gathered so far to help you decide whether and how to use a model like this. And we're now moving into the super technical part of the presentation, because if we were to use it out to grade our own notes, we'd want to know exactly how it works. We'll be putting some of this onto YouTube later, so if you want to send a link to get when it's published in a couple of weeks, let us know in the chat. This is it. This is our code. Chris has the Python script open right now, and you can see it there. If you want to, you can follow the GitHub link, but it's pretty simple, and we designed it that way. Before we get into the weeds on the grader, we wanted to talk about how AI is changing the way that we think about coding. I'd expect that the vast majority of medical educators are pretty comfortable with most technology, but don't really do much actual computer programming. So turning your ideas into functional computer language is probably the biggest barrier for most of us to start using AI in any sophisticated way. And that's okay. You can easily do everything that we'll show you here with the help of AI if you're willing to experiment a bit. So if you've always wanted to learn to code, now is the time. What Chris is doing right now is he is doing something called vibe coding. Essentially, he's asked ChatGPT to write a Python script where you control a blue circle that tries to touch a red square while avoiding green triangles. And you can see the code that it's generating right now. It starts by looking at what does the size of the box in the game that you're playing with. Oh man, that's really fast. It's so much faster nowadays. It's showing you the positions of the player. It's showing you what does the enemies look like? How do the enemies move across the screen? What does it mean to win this game? It just essentially spat out all of that code immediately. And so all he needs to do is he's going to jump back into Visual Studio where this code lives. He's going to upload the text that he just wrote using ChatGPT into Python. He's now asking Python to run the script. He's commanding that python.exe, I want you to run this game. And then boom, he is playing a game. That's a game that literally he just coded just now. That was, you went, good job. That is not a simulation. This is where the technology is headed. He just wrote a video game in seconds. If you wanted to, you could ask the machine to go back and edit the code so that we could introduce all sorts of other concepts. For instance, in this case, we're going to add a timer to the game, so you can't just sit around and let it happen. He's doing this all with just his own natural words. He's just plugging in the words, hey, I want to just let me play for 30 seconds. Can you keep my score in the top corner? And so now what ChatGPT is doing is it's going back into the original code that he's already written, and it's going line by line to integrate it back into the original system. This isn't just adding it on like a Band-Aid. It's as though it was supposed to be there the whole time. So this is the first alternative use for this model. It's an easy point of entry to start experimenting with AI and playing with code for sophisticated med-ed tasks. If you ask it to alter the code so that instead of just grading, there you can see the timer is now up at the top of the screen and he's keeping score, which is super cool. And so now it doesn't just automatically end. So you can ask it to alter the code such that instead of just grading your notes written by your students and explaining why it took off points, maybe you also want to give the student dedicated feedback. Or maybe you want it to run calculations comparing AI scores to human graders to see how closely the grader resembles your historical grading performance. Or maybe you want it to tally all the wrong answers the students gave to see where students are getting stuck. All you have to do with ChatGPT is just ask it to do those things. And so this is a video of us demonstrating that in real time. Essentially, we use ChatGPT to assist in the coding and developing process. And you can see what Chris is doing here is essentially debugging our program with the assistance of ChatGPT. Importantly, for their documentation, when you use the API, ChatGPT doesn't retain or use submitted data to train its models. This ensures that even though we are using anonymized student data, the information remains secure and isn't stored by ChatGPT for training or any other purposes. For the purpose of our system, we used ChatGPT 4.0 and tried a bunch of different strategies until we started to get reliably consistent results, especially compared to the less structured, just throw the note at ChatGPT and hope for the best approach that Chris did earlier. Of all of the strategies that we used, two of them stood out. First was chain of thought prompting. And if you've done anything in artificial intelligence, you may have already heard about chain of thought prompting. This essentially guides the model through step-by-step evaluations. It breaks the problem down into smaller, logical steps. Instead of asking it to just flat out grade an entire note on 9 different rubric domains at the same time, it grades just by the history and then just the physical exam. This is based on some research by Chris Runyon that he presented at NBME's NICE conference that demonstrated clear improvement using chain of thought prompting for this specific application. The second important strategy is asking the model to perform self-reflection. In this context, we ask the LLM to justify its grading decisions. Theoretically, asking the model to explain itself before assigning scores causes it to reflect and reanalyze the output. It literally forces the algorithm to say, wait, does this actually make sense? Every single time. We graded tens of thousands of notes this way, and it takes a lot longer and requires a lot more computing power. But based on our evidence, it shows that this means the model is asking it to justify itself is more important than just giving us or the students a rationale for why it took off points. It's actually making the model more accurate. These are strategies that are described in the AI literature more broadly. But when we were prompt engineering this tool back in the middle of last summer, they were still relatively new concepts. And we were pretty proud of ourselves for having improved the model performance. Of course, now both of those techniques are leveraged by default in ChatGPT 03 and 04, but notably not in 4.5, which speaks to the utility of this approach and how rapidly the technology is evolving. Anthropic, Google, DeepSeek, they're all leaning into chain of thought, and we have been told that it'll probably be standard by the time ChatGPT 5 drops. We wanted to briefly talk about fine-tuning, which is the process of training the large language model to understand your expectations by giving it examples of what you expect the output to look like. In our case, what that means is feeding it notes that we graded by hand so that it knows what to expect from a 4, from a 3, from a 2, etc. This video that we were showing earlier is actually an early attempt at fine-tuning. We tried different versions of it, tried to teach the AI to recognize our specific grading patterns so that it understood how we think and how we should use our specific rubrics. It's a lot like training a new faculty member with examples. However, after trying it both ways, we decided to go with an off-the-shelf zero-shot model. This is where we don't give the LLM any examples of graded notes at all. We just ask the basic ChatGPT to grade the note. And we did this for several reasons, but one of them bears a moment of consideration. Because we're using real-life data, we didn't want to inadvertently train the machine on any of our graders' implicit biases. And now I'm not saying that I'm concerned that our graders are more likely to score someone higher just because they sound smarter, like using more syllable words or complex sentence structures, but I am saying that I didn't control for that in a data set from real-world data. So how many other biases would we not even be considering? So like I said, for several reasons, we decided to go with a zero-shot approach. This also gave us a couple more advantages. One, institutions won't need to generate gold standard, expertly graded, bias-free notes to train these models. And two, we didn't want to risk overfitting if the basic model would perform just as well. However, in some scenarios, fine-tuning could still be very useful. If you're dealing with highly specific use cases, unique rubrics, or need the model to provide detailed student feedback, fine-tuning might be the right choice for you. While this does risk overfitting, like we mentioned, that might be a good thing if you want the AI to match your historical grading patterns. It was bittersweet to see that this was the same approach described by the UT Southwestern group in November. So if you guys are listening in, good work. We corroborated your approach. And we're definitely not super jealous. Like the New England Journal is a big deal. So let's actually demonstrate how to set up this grader at your own institution. When we first started this project, the goal was to create a simple plug-and-play website or a plug-and-play program or a website where you can just upload your rubrics and your cases and you'd be done. And we're almost there. In the meantime, we still need to prepare the students' data to be in a format that the LLM likes. And so we started by exporting the data from our system into its own Excel file. Conveniently, this data is anonymized and exported very easily. This is how the raw anonymized data looks. Each of those rows is an entire different student note. The columns are different sections of the note. Each student's entire HPI is contained in each row of that first column. The numbers after each input, the numbers after in columns B and C, are how the faculty graded the responses for that section, according to the rubric. Each domain, in our case, can be scored from 1 to 4. And when exported in a text format like this, the LLM can easily handle this data. Most data management software platforms can do this by default. The student notes are ready to go. We're going to call this the student note data. So now let's look at the rubrics. This is the original grading rubric used by our faculty graders. There is scoring criteria for sections like history and differential and overall organization. All of our OSCEs share a common format, so we created a standardized template using this format. Because the API works best with structured text, we converted the PDFs into Excel files to make them easier for the model to process. The converted files are shown here. We kept a similar design philosophy to the student note data, and you'll see that each of the columns holding the grading criteria for a different section of the note. This is done for two reasons. It demands less computing power for the LLM to figure out how to use the rubric that we've given it, and it makes it easier to ask the LLM to use chain of thought reasoning, which, as we said, gives us more reliable data. I'm going to call this the standard rubric. And so after creating our standard rubric, we could then abstract out the features particular to each clinical case. For instance, different components are expected to be documented on the physical exam for a patient with knee pain than you would expect for abdominal pain. And we converted these case-specific elements into their own key files. This matches the standard rubric, making it easier to code and easier for the LLM to keep track. And we're going to call this the case-specific rubrics. So now your student notes, your standard rubric, and the case-specific rubrics are all ready to be used by the LLM. The next step is to execute the script that contains the text prompt instructions for ChatGPT to actually grade these notes. And the output is your graded notes. We captured both the numerical scores and the reasoning for each rubric domain. This is how the prompt actually looks. There's a ton of text on this screen. These are the instructions that get sent to ChatGPT when grading the history. This is just the history portion alone. At the beginning, there's some basic prompt engineering to give it some context about the task. I am a medical educator and I am grading an assignment. And then it goes into some rubric, some prompt engineering to ask it to grade the history based on this rubric. The Python code then references the standard rubric in the case-specific rubrics, then looks at the student's written HPI and evaluates that section of the note, reasons through it, gives it a score, and then it moves on. And that's the whole process from beginning to end. To summarize, if you want to get this started at your own facility, all you have to do is write a script, a Python script that handles your notes and rubrics, summons ChatGPT through their API, and sends the rubrics to your prompts. The LLM does all the grading. On the back end, because we're using a chain of thought reasoning, it's actually submitting completely different prompts for each individual section, the plan, the differential, the HPI. Our rubrics have a section for organization at the end. In this portion, the prompt asks the LLM to review only the organizational structure of the entire note and holistically output a single grade. So this is the code that Chris wrote. And again, it's relatively simple, but if you've never coded before, it can look incredibly intimidating. Like we said, this is probably the biggest barrier to anyone deploying it at their own institution. If you need some help getting it up and running, we would be happy to help you out with it. Just let us know. You saw Chris execute this code already, but at the top you can see the entire command. You essentially select the model, the rubrics, the notes, and set some parameters like temperature, which we'll talk about in a second. If you want to get really fancy, you can take it a step further and batch the notes with PowerShell in order to grade them all at once, or grade each note numerous times in order to check for consistency. So let's just check back in with the grader. That is the game that we wrote. He's flipping back and looks like it's done. Great. It was done in about 9 minutes, which is awesome. So he is going to pull up what the actual grades look like. And so, as we talked about, each of these rows is a different student's note and the HPI, and then how they graded it on the sides. And you can see that the majority of students got 4s pretty much across the board. A couple of them got 3s here and there. There are a couple of 2s, but that's it. That's all there is to it. If you wanted to, like we said, you could augment your code so that it had explanations, so that you could give students feedback, so that you could do all sorts of different things using just this same system. That is Chris's dog who's playing a Stratocaster. So it can be done. It works. It generates scores. It's pretty quick and very cheap. It only takes a couple of cents to do what we just did. You could choose to deploy it in many ways. It can grade all of your notes, or you could choose to hand grade the bottom 10 to 20%. You could use it as a physician in the loop approach, where graders could see the AI suggested scores and reasoning as they grade their own, or you could use one of the alternatives. But getting back to our main question and the focus of our research, given the concerns for non-determinism and for hallucination, how can we prove that this generation of AI is reliable enough to trust with your students' grades? Specifically, if you run this model on the same set of data multiple times, how consistent are your results? How often does it produce the same scores, and what does that variation in scores look like? So we set out to answer those questions and measure reliability to ensure that the algorithm was consistent with itself when it's asked to grade the same note multiple times. A manuscript with this data has been written and hopefully will be published. We first compared the interclass correlation between the two human graders in our dataset and found that they had an ICC of 0.88. That is very high agreement with each other, which is great for the University of Kentucky, but I am ethically bound to add the disclaimer that we are using real-world data for this study, and the two graders are not blinded to each other. When we ran our model 30 times using the same notes, it had an ICC of around 0.76. This is also very high reliability. So even though the technology has a reputation for hallucinations, when prompted in the right way, it tends to be consistent with itself. It's important for us to slow down and understand why the AI might give us different scores despite using the exact same notes and rubrics. Take this note, for example. This was a 60-year-old with right-sided flank pain. History reads like a textbook kidney stone. At the bottom of the third paragraph, he has had such bad pain that he is vomiting. When we asked the LLM to grade it multiple times, the grades were evenly split between a 3 and a 4. Half the time, it deducted points because the student did not include a numerical severity or the word severe in the history. This is a required rubric element, and the student doesn't describe the vomit as bilious or non-bloody. You can see all of that stuff here. Right-sided pain, which travels down to his groin, does not have any kind of qualifier there, but later says that the pain is so intense that he will have nausea and vomiting with the spasms. This is true. The student doesn't specifically state the severity of pain in their HPI directly, but they did say that it hurt so much that it made them throw up. So if you were the grader, would you assign a 3 or a 4? Is almost all the key detail present, or does it lack some detail? You could make the argument either way, and the LLM is going to reflect that. And you can see the GPT reasonings on sometimes when it grades it a 4 and sometimes it grades it a 3. Which brings us to the next alternative use for this model, which is rubric development. We propose that this inconsistency within the LLM isn't a random hallucination or an error on the part of the AI. Instead, it shows us where our grading criteria may be especially open to interpretation. When you look at the way that we grade, the way that we ask our human graders to grade, it's built into the rubrics. Our rubrics use terms like almost all for a 4 and most for a 3, and many key findings are omitted for a 2. These terms are vague, so it's not surprising that a computer model sometimes wavers between two scores. Because our rubrics allow for variability and subjectivity, we don't expect perfect agreement from human graders, and we shouldn't expect that from an LLM either. But we think this variability by the computer is actually an opportunity. By running the algorithm multiple times on the same notes and calculating the ICC for each domain, we can pinpoint where our rubrics need improvement. The AI's sensitivity to ambiguity, combined with its ability to brute force test thousands of rubrics, makes it a powerful tool for rubric refinement. Low ICC values, like on this graph, things that are more on the left side of the screen, highlight sections where instructions may be unclear or definitions too subjective. This system could help us make sure that every scoring point is tied to a clear, objective standard, which is not only more reliable for an AI, but also for human graders. In this way, AI is doing more than just automating the grading. It helps us build better, more transparent, and consistent assessment tools. Once you have the grader up and running at your own institutions, it's relatively easy to edit the code with ChatGPT to grade the codes 50 or even 100 times and calculate the ICC for each section of your rubrics like we've described here and will describe in our manuscript. This, what he's showing, is how you integrate that into the ChatGPT code, or I'm sorry, into your Python code in that section, that function to calculate ICC for given columns. So back to our numbers. Now it's time to talk about validity. It turns out that both the human graders and the AI were each internally consistent with themselves. That's very promising. So is this it? Does this thing actually work? Have we finally liberated the dutiful grading faculty of the University of Kentucky from the hours upon hours of grading OSCE notes? What happens when you compare the AI to human graders? It turns out there's disagreement. The ICC value here is negative 0.016. But wait. Stay with me. The average score assigned by humans across all notes was 3.6 out of 4, while for the AI, it was 2.95. Overall, the AI is a much more hawkish grader. However, when we went back and reviewed examples where humans and AI disagreed, we mostly sided with the LLM. Remember, we are using real-world data, and real humans are grading high-stakes exams, and these grades show up on the students' MSPEs. So maybe human graders are just more likely to give students the benefit of the doubt and award points when ChatGPT is this uncaring, soulless machine. Either way, we wanted to understand whether the AI was bad at grading or is it just a very strict grader. And so we calculated a Spearman statistic. We obtained a value of 0.53, which is a very strong correlation. And this means that while the LLM does not completely align with the absolute scores given by human raters, it still ranks students similarly. So the students who score higher by human graders are going to be ranked higher by the AI and vice versa. And this is promising for validity, because if we get the same general ranking using the AI system, maybe we just need to adjust the grade cutoffs for our students to emulate human grading. We might not be ready to completely turn it over to the machines just yet, but damn, it sure does feel like we're close. And this is where the project gets really exciting. The AI is giving us reliably consistent data that resembles the more hawkish human graders. Plus, it's quick, it's easy, and it costs less than $1 to grade a whole class's notes. Coupled with using this technology to improve your rubrics and your instruments, this process has real potential. So next, we wanted to talk briefly about temperature and top P. You may have noticed that we had included that ability to set those parameters in the code itself. These are settings for a large language model that are typically associated with randomness and creativity. When using an LLM to grade notes, these parameters may determine how the model interprets and apply your rubric. On lower settings, the grader should adhere more strictly to the rubric. Setting these parameters too low, however, could theoretically produce rigid and overly literal interpretations of your rubrics. This is what you would expect from a machine grader from 10 years ago. It makes for consistent scoring, but penalizes legitimate clinical reasoning that doesn't match the rubric word for word, like not including severity for pain, as we saw earlier. On higher settings, though, the model may grade more creatively. If you set it too high, it may consider even loosely related elements as correct. And while we want some amount of interpretation, too much makes grading less accurate and less predictable. An optimal combination of these parameters may exist for this purpose, but it hasn't yet been described in the literature. The best parameters might also depend on the type of rubric that you're using. For instance, an exhaustively detailed checklist-based rubric might benefit from less randomness, as the LLM would function more like a word finder or a bean counter. In contrast, more holistic rubric like ours might benefit from more relaxed parameters and higher temperature. Or it might not. This is where we need further research, and we're going to talk about that soon, but the prompt engineering is continuing to evolve with this technology, and we need to keep up. Before we wrap up, we wanted to share one last alternative use for this system. One of the biggest challenges in medical education is giving students timely and consistent and useful feedback, especially in large classes. This is real feedback on a real evaluation. It just says missed hypothyroidism. This is the way that we give feedback currently. Typically, our graders will leave a few words per section to explain point deductions, and they'll say missing smoking history. Using AI, we can potentially provide personalized, detailed feedback that addresses each student's specific needs. You could design a prompt specifically to give students constructive feedback, highlighting strengths and weaknesses and providing recommendations. It could tailor feedback to students' training levels, offering simpler guidance to first years and more advanced suggestions for fourth years. These are all just highlights of the ways that you could choose to use this system. And there it is, it's all yours. We're finishing the paper and have an IRB submitted for a study that comparing it in real time against human graders. But should you use it? Your rubrics are going to be different from ours. How do I know that this is going to work for you? The reality is that we don't. And that's why we wanted to close with a collaboration. These large language models have only been widely accessible for about 2 to 3 years now. And we're already seeing an explosion of innovative uses like this in this conference. This is truly just the beginning of the age of artificial intelligence in medical education. But we think we need to move beyond this novelty of the wow factor of this is how you can use AI. This is where AI shifts from flashy demonstrations to a disciplined tool for solving real-world problems. In this next phase, the question isn't whether AI can do something, but what is the best way to optimize its performance in a rapidly changing landscape. And there are many people out there who built different versions of OSCE graders, each using different approaches with varying amounts of success. We think that the next phase for AI in medical education research is to systematically compare these different methods to identify the most effective, reliable, and evidence-based ways to use AI for assessment. This phase is about setting the standards and the best practices that will shape how we deploy AI in our medical schools, which is where open source collaboration is going to become indispensable. And to that end, we've published our code so that you can experiment with the prompts and adapt the model. We expect that as our community really starts to use AI, that your approaches are going to blow ours out of the water. And we hope that they do. So we want to invite anyone who has built an OSCE grader or wants to build one over the next several months to join us. Or similarly, if you just want to play with LLMs and AI in general, let us know. We want to evaluate all of these things side by side and figure out the best way to deploy AI. From there, we'll see how they perform in real-world settings, testing them on as many different rubrics as possible. All the data, the results, and the insights should be published openly so that every institution won't have to start from scratch like we did. While this starts with OSCE grading, we should do the same with comparisons on ambient listening systems for grading communication skills, or patient simulators to practice ethical dilemmas. And we think this is the future of AI in medical education, collaborative solutions that can save our faculty tens of thousands of hours. If this philosophy of open collaboration resonates, we would greatly appreciate your help in spreading the word. We're going to be publishing this demonstration on YouTube. You've got this link to the SAEM webinar, and so spread it around however you like. If you need help getting this process running at your own institution, let us know and we'll be happy to consult. Finally, I wanted to bring up that this Friday, we're hosting an Innovators in Medicine Grand Rounds featuring Sully Chen. Sully is a third-year medical student at Duke who has been on leave working with OpenAI as a staff research assistant. They are the company that created ChatGPT, and there's only 700 employees there. And so Sully is super fascinating guy, and he is interested in AGI and how that is coming for healthcare. So if this conversation about LLMs for healthcare is interesting for you, check us out. It's a joint presentation with student groups from UK, Duke, VCU, Old Dominion University, and the University of Louisville. And if you want to join us and partner with us, join our little steering committee for this, just send me an email. We're working on offering CME credit for it, but we want to create a platform to share more ideas about AI in medicine and medical education and figure out ways to network and collaborate. Finally, if you want to hear more from Chris Nash and me, if you want to hear more from us, check out this episode of the MDM. It's a podcast about the ways medicine is adapting to the modern world. Chris Nash was the guest back in February, but it was recorded all the way back in September of last year. So it's like a little time capsule. You can see where we all started. While we're on the subject, also relevant to all of us at SAEM is this most recent episode called Doing Time. As EM residencies are grappling with converting to a standard 4-year curriculum, this is a conversation with some EM program directors. Some listeners actually reached out and wanted to make a rebuttal episode. So things are starting to get a little spicy over at the MDM. We're planning to record that episode at the end of May. So if you have strong opinions, want to share your perspectives and be on the show, send me an email. You can find the MDM anywhere that you get your podcasts. Thank you so much for your time. That is it from us. And a very special thank you to our mentors, Dean Jen Kogan and Professor Larry Gruppen, and to everyone else at the NBME for their incredible support, including Boris Villich, Kathleen Leary-Elderkin, Raja Subbiya, Kevin King, Chris Runyon, and Victoria Yaneva for supporting our vision and teaching us what rigorous assessment in AI research truly is. I am now going to turn it over to Chris for any questions because he can handle all of those technical questions so much better than I can. And then if anyone has any other questions or wants to jump in, please let us know. We were told that most of these SAEM webinars are usually watched remotely. And so if anyone who's working out in the world has any questions about anything that we just talked about, like I said, you can reach us. He is chris.nash@duke.edu. And then I am tama.te@uky.edu. That's tama.the@uky.edu.
This was awesome. Thank you guys so much.
Of course. Our pleasure.